Okay, this performance expectation is A1.3.C. So evaluate f of x at A and solve for x in the equation f of x equal to b. If my function is f of x equals 3x minus 11, there's a couple different ways I can do the first part. If I want to evaluate f of x at A, I could say a couple different things. I could say x is equal to 3, or I could also say something like f of 3. Either one of those things is a way of representing the idea that x is equal to 3. You can see here my x's are equal to 3 here, and here this x has been replaced with a 3, so they mean exactly the same thing. So if I'm plugging this into my equation, I take this 3 and I put it right in there and replace my x with that 3. So it becomes 3 times 3 minus 11. So then I just go through PEMDAS. I solve this first. 3 times 3 is 9. And the minus 11 part still comes down the same way. Then 9 minus 11 is equal to negative 2. And that's my answer. So my f of 3 equals negative 2. And that's how you do it the first way. Now, a totally separate way of doing these things, and a completely different problem, is to try to solve for x in the equation f of x equals b. So I'm going to use the same problem again. So this time it will be f of x equals 3x minus 11. So in this problem, if I asked you to solve for x, if I told you that, I need to do that in red. If I told you that f of x equals, let's say, negative 8. So if I was solving this whole thing and I said f of x equals negative 8, I don't want to replace that x with an 8 because this is what f of x equals. This goes over here. So then I would say negative 8 is equal to 3x minus 11. Now to solve this problem, I have to solve it using algebra, which means I need to work backwards from PEMDAS. The easiest thing for me to do is to get rid of the subtraction. So the opposite of negative 11 is going to be adding 11. Those end up canceling out. And I end up with 3 is equal to 3x. Now, if I was going to solve this one step further, to get rid of this 3 times x, I have to do the opposite, which is divide by 3. That cancels both of those out, and here, 3 divided by 3 is just 1. That is equal to my x. So, when x equals 1, if I plug that back up into here, that should give me f of x equal to negative 8, which, if I wanted to do a check step, I could see that plugging in a 1 in here for x would eventually end up equaling negative 8. So that's how you do both parts of this performance expectation.